Hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company providing technological solutions across the world. Now, in our this bootcamp session, we are going to see how to build a spam detector using PyTorch, right? RNN, recurrent neural network. See, in our last few bootcamp sessions, we have seen different type of techniques, right? So in this session, we are going to see how we can detect a spam detector. Now see, the basic concept of this PyTorch is to get first historical data, then separate the dependent variables and separate the independent variables. After that, we create models and then we train the model. That's it. That is the basic concept. So now let's see this. First of all, RNN. Here we are using recurrent neural network. Now what is recurrent neural network? Let me iterate it again. Recurrent neural network, or RNN, is a deep neural network trained on sequential or time series data to create a machine learning. That means it's a time series data. That means if you take the historical data, for example, like sales order data, let's take any corporate data like transaction data. So sales order data, that is based on time series, right? So take like 2020 data, then 2021 data, and then 2022 data. So based on that, we can predict what type of whatever we want in future. So in this way, we can predict the data for the future. Same thing is here. Now if you see here, RNN, recurrent, there are two types of models: convolutional neural network and recurrent neural network. Now convolutional we have already discussed many times in our previous sessions. So now here you will see the RNN neural network. So RNN neural networks work on input layer. First of all, let me explain you the scenario of this agenda of this session. The scenario is, we are having several amount of emails, and out of which there are few are spams and few are not useful emails. Now our target is to build a model that can separate the useful emails in a different folder and spam in a different folder. That is our business problem, right? See, PyTorch, all these machine learning and deep learning models, they are designed to help business and the daily life. Normally we take it as business models only because they help in business, right? So this is our agenda of today's session, that we are going to design a model that is capable enough to separate the useful email in a separate folder and spam in a separate folder, right? So that is our agenda. And now let's see again recurrent neural network. What is this? See, it works on, it takes the input layer and then works on a few hidden layers, and then the output is shown here. Here you will see it is having, the name is recurrent neural network. That means whatever the previous output was, previous input was there, it is stored somewhere into the memory, right? And then based on that, it is checked again and again. For example, suppose, let's take an example. If I go to a friend, and then there I see a calendar on a wall, right? Next time again on another day, if I go to friend, I will see there is no calendar on the wall. So I will check that, okay, on certain day he hangs that calendar on the wall, and then on certain day, that means in my previous memory somewhere the day is also captured, right? So on the basis of that, I will train myself that, okay, on this particular day, that like Monday, Wednesday and Friday, he hangs that particular calendar on the wall, and on remaining days he does not hangs that calendar, right? So this is called working on previous memory. Same thing is here also. I am giving you a real life example, and you can relate that real life example with this. So same thing is here. its own memory. There is somewhere hidden memory here, and then in that memory the previous data is also stored, and based on that it takes the it analyze the data. Look at this. How does recurrent neural network works? Same thing. It is stored in the memory, and now again the new state is analyzed here, L2, L3, like this, right? Look at this formula here. It is written H2 new state, H is new state, function with parameter C, old state HT minus 1. HT minus 1 is the previous state, and the input vector at time step 1. Input vector, whatever the input. Suppose again I am giving you the same example. I visit to my friend on Monday. I saw that calendar is hanging on the wall. Again on Tuesday I visited my friend. Now I see there is no calendar. Now somewhere in my memory back I stored that okay, yesterday it was there. On Wednesday again I saw, yeah, it was hanging. So based on this continuous process, then I will come to a conclusion that okay, on certain days of the week he hangs the calendar on the wall, on the certain day of the week he removes that calendar from the wall. So that is called how the recurrent neural network works. So previous memory, whatever the previous output was there received by this, it is also involved in the taking decision, right? Now if you see here types of recurrent neural network, you will see one to one, second is one to many, then the many to one, and many to many. That means whatever the previous output given by the last hidden layer, that is also involved, right? So in this way it works. Now the question is why recurrent neural network is used. See, it can handle the sequential data, right? Sequential data means the things, the activities that goes sequentially, like I visit to friends sequentially, one day after day, day after day. For the whole month I visited to my friend, so it's a sequence. Then consider the current input, also the previous received inputs. Just now I given you example, the in back of my mind somewhere I saw that on Monday the calendar was not there, so I involved that also, that input also, and based on this I come to a conclusion finally that on certain day of the week he hangs. Can memorize previous input due to its internal memory. See, if I give you directly this practical example, it would be difficult, so that's why I am adding this practical life example, right? Now you can understand, you can relate how this neural network works. All the concepts are taken from human brain only, right? So now if you see here, now our next target is today's agenda. We are having so many incoming SMS. Now SMS spam filter, we are creating a spam filter, and it can be able to separate the spams and SMS. Now how do a human brain works? Now see, suppose I receive daily several emails. Now in few emails I saw congratulations, the company, the X company has given you the loan of 25 lakhs. You can win this and click the below link. Now easily I can understand it's a spam, right? So the very first time when I saw this email, even I was also thinking that it might be a current really true email, but that's not the email. So very first time when I saw, and later on after coming through these type of emails, now I am able to understand which emails are spam and which emails are not spam. So this is the human brain, that you can memorize the last memory and you can recall that last memory, and then you can come to a conclusion. But how this can be done with the help of machine? So that is why this machine, we train the machine with the help of historical data, right? In real life also, if you see any mail, then immediately your brain will recall the previous memories that okay, don't open this email, right? For example, if someone if a person is having suppose someone has done a fraud with a person, like sending a spam email and giving what we say, the APK file right, and he installed that file in his mobile. Now next time if someone says that okay, install this apk file, android file on your mobile, definitely that person will recall his past memories, and then he will say that no, it's a spam, right, it's a fraud, right. So in this way, a person can detect. Now same thing we can do it with the help of machine learning. Now see here, SMS spam detection process, how it works. Here you will see data, text message received, it will clean the data cleaning, then TF IDF representation, then traditional machine learning concept, classification concept will be used, and then spam and not spam will be identified. I will show you practically also. Now see where these applications of RNN are used. Application of RNN, chatbots and virtual assistants. You might have seen many emails where many websites where you will see some chatting assistant, right, chatting assistant. In that, let's take godaddy.com. If you open godaddy.com or any domain website where you can purchase the domain, you will see immediately when you say hello, then the next question comes, how may I help you, and for what purpose you are buying this domain name. Then you will reply, and then based on that reply again another question comes that okay, if you want monthly subscription, yearly subscription, then again you will reply. So in this way the question and answer goes on, and finally you will come to know exactly the machine will understand exactly for what purpose you want a domain, and so it will suggest you some names. Similarly, in some recruitment websites, or we can say job websites, you will see the job websites, they take inputs from you that how many years you have completed this, and how many years of experience do you have. On the basis of that, the machine, the website suggests you the jobs which are perfectly suitable for you, right, and this is done by totally machine learning, right, AI. So predictive text and auto completion. Predictive text and auto completion means you, if you see if in your mobile, whenever you write text, if you write will call you once, I reach, after that home, office, these are predictive text automatically shown on your mobile text box. On that, on the above the keyboard, you will see these predictive text are coming. So that is called predictive text and auto completion. You will see stock market prediction, that we have already seen in our many of our videos. Medical diagnostics, video analysis. Video analysis is also one, and then the language translation, which is largely used by Google Translate, right. So this is how recurrent neural network is used. Now we are going to check here. Look at this. We are having a list of correct emails and spams, and now we are going to feed this email list, complete email historical list, to this machine learning, and then based on that the machine will learn itself, and on the basis of that it will identify. Then we will, what we will do, we will try to give this machine an example, and on the basis of that example we will try to see whether the machine has learned perfectly or not, right. So that's the concept here, and now today let's see this. I am creating a new IPyNup file, that is interactive Python notebook. Okay, why I am repeating always this, because you should memorize IPyNup file, interactive Python notebook, IPNB. Okay, so spam detection. Okay, spam detection model 2. Okay, now I have already created. Now first of all, what we all need to do, that is bringing the libraries. Now here import torch.nn, that is the neural network, optimization, matplotlib for plotting the data, sklearn model, selection, train, test, split, right? Features extraction, okay, this is vectorization. These are some special libraries. Sklearn matrices, accuracy score, classification report, and pandas for a very well known and popular library for cleaning and massaging the data. NumPy, that is NP. Now I am going to hit the enter button. Now this you can see here it is working, and another you can see the asterisk sign here, that means it is working, still working, right? We have to wait for 5 seconds. After that you will see, let's wait. So this is the basic concept, and you can apply this formula on any type of situation, any type of conditions given to you, right? We have seen the loan default example, we have seen the diabetes, whether a person, suppose we are having a set of so many patients, diabetic patients, and we are having the history of so many diabetic patients. We want to apply this RNN, recurrent neural network, or CNN model to detect now what are the symptoms. Based on the symptoms it will easily detect. Now let's come to the next, that is, here you will see the load the data set. Now load the data set, let me show you first. You will see here SMS spam record, SMS spam record. Which are spam, which are not spam, let me show you. Look at this, ham means it's not a spam. See here, so I pay first, right? So I pay first. When you use if I show you some example of spam, just a second, let me go upside and put the filter here, make it as, if I want to show you spam, look at this, spam means free entry into weekly comp to win, competition to win, free message, hey there. Now spam looks something like this. You also might have experienced in your life, in your email, that, look at it. Now these are the, I'm gonna be home soon and I don't want to talk about this stuff anymore tonight. These are some like these are the messages given by humans, right? So what we are going to do, we will provide this both the data. Now we consider here ham and spam, right? Right now ham, just consider ham means it's not a spam, no spam, right? After that, let me close this, okay, right? Here you see ham means no spam, it's a technical word, so just you can imagine ham means no spam, or you can say human message, and spam means spam, right? Okay, now what we are going to do, first of all, SMS spam record dot csv, we have taken here csv record first, pd dot read csv, pd pandas, right? So panda is a very well known library. Now df v1 v2, v1 label and v2 is the message, right? So label and message, df columns. So what we are going to do here, if I print here df, look at this, label and message, that means here we have changed the label and the message. v1 and v2 was there previously, right? So we are going to change this. Okay, now what next we need to do, just a second here. Now see here, encode labels ham equal to 0 and spam equal to 1. Ham means it's a human message, that is 0, and spam means yes, it's a spam, that is 1. Now what we have done, we have done the label, one more label, df label equal to df label map. That means it will work like 0 and 1. So if I click on this df, you will see 0 and 1, because this RNN and all, they work with numerical data only. Okay, now let's see this vectorization. Now we are going to vectorize this. Okay, now see vectorization using IDF, sorry. Vectorizer equal to TFID vectorizer max features, that is 5000, X vectorizer fit to transform message to array, and Y vectorizer, that is label values. So see here, the basic concept is to separate the data into independent and dependent variable, right? So here what we have done, X and Y. X is the independent variable which is already there, and Y is the dependent variable that will be derived. Okay, now if I show you, now the next step is train test split, right? So train test split, so again there is one function, that is train test split. So whatever the array we have received, so x train x test, that whatever the df is stored into the x, and y train y test means whatever the data that is stored into the y, and among these x data, 80%, 70% of data is used for training and 70% for testing. Similarly, from y data, 70% is used for training, 20% for test, 30% for testing, right? And random state 42 means it will never shuffle the data. Every time, if you you might have seen the command of RAND, random in Excel sheet, right? So if you click on that, you will see each time when you enter that button, the number changes. So here also we don't need those numbers to be changed, so that is why we are using here x train y train x test y test, or x train x test y train y test, right? So now I'm going to hit the enter button. Okay, now convert to PyTorch tensors. Okay, now we have done it. Now we are going to convert it into the PyTorch tensor. See, everything is based on tensor only, right? If you go to face detection machine, that is also, it will check your take a your photo of your face, and then it will convert it into tensor, and then will match the images which are already stored into its database. And where 90% tensor is matched, that means it will consider that the person who is in front of the machine, that is the genuine person, he is not any other person. Okay, so you can see here we are going to convert it into the tensor, and now I have converted it into the tensor. Now let's see this again. Now our next task is to create the RNN model. Okay, now RNN model, what is this RNN model? So class spam RNN and then NN dot model, right? So we are taking the model, and here is a standard format of that. If you go to this forward function, right, forward function, right now this is just a model, right? We have not put anything here right now. Now we are going to put the data. Let me explain you here. Now you can see here input dimension, that is xtrain dot shape. After that, shape is 1 only, hidden dimension 64, output dimension 1, that is the spam or ham, whatever the output is there, number of layers, that is 1, and learning rate, that is 0.01, and epochs, that is 100. The 100 repetition we are going to apply on this data, and then based on that 100 repetitions, it will be able to recognize that what is spam and what is the original genuine email, right? So now these all things they are put into this machine, right? Everything input dimension, xtrain and ytrain. Now look at this model equal to spam rnn. This is the model that we have created earlier. Now this input dimension, hidden dimension, that is hidden dimension. All this data is put into this particular model, right? Okay, now you will see here. Now our training loop begins from here. We have done the model. Now our training loop. Now training loop epochs. You will see here the epochs is 100, right? So train losses, we have created an array of train losses, and then epoch in range, that is the 100. Then model dot train. So whatever model we have created, this model, right? This model dot train. After this, you will see the optimizer 0 grade, then outputs mode, and you will see here train losses, right? Train losses we have we have extracted, and then now you will see prediction. Okay, now I'm going to hit this enter button. Now the epochs is running, wait, right? So you will see here initially accuracy is 93%. Now the accuracy, next time accuracy increased and this loss decreased. You can see here 98%. Accuracy again increased, loss decreasing. Look at this. Previously it was 0.32, now it is 31. This is decreasing and accuracy is increasing. Look at this. We have to wait. Now you see here initially the loss was 72%, now it comes into 31%, and initially the accuracy was 93%, so it increases up to 93%. So that is called accuracy increase and loss is decreased. Okay, now what will be our next step? That is plotting the training loss. Now we are plotting the training loss, right? So here is the plotting and plotting PLT. PLT is used. PLT means, here you can see sklearn, here matplotlib.pyplot equal as PLT. Now you can see here training losses over epochs. So after every epochs it reduces, right? So loss is decreased, right? So now what next we are going to do here? Now we are evaluating the model, right? We are evaluating the model, so the accuracy is 98%, macro average, that is 96%, and weighted average is 98%. Okay, so now this is what we have derived, and then okay, now you see here now what we are going to do, we are going to predict a new message. Now we are going to give a message, and then we are going to give a message, and then we will check that whether it's whatever it is, right? Whether it's a spam or not, right? So So I'm going to hit the enter button here. Now you can see two messages we have given, right? So how it worked? Congratulations, you have won a $1,000 gift card. Call now. It's a spam. And hey, are we still on for dinner tonight? So it's not a spam, it's a messaging. It's a human message sent by the human. Okay, so it has successfully identified, okay, which one is spam, which one is not a spam, based on the historical data. So guys, how it worked, right? How it worked, again I am repeating my same example. When I visited my friend, I come to a conclusion that on some specific day, then when on the next month, if I go any day like Thursday, then I will easily identify, okay, this time the calendar might not be on the wall, right? Same thing is here. If you go through this approach, that connecting real life examples with this, then it will become much easier to understand, right? Let's have again a quick recap on this, exactly what we have done and how it worked, right? Okay, I am opening this. First of all, if you see here, the repetition of the same example again, the purpose is that when you will listen same thing again and again, you will memorize it. You don't need to put your extra efforts on it, right? That's the reason. Okay, now recurrent neural network, it works on n number of hidden layers, and the reason is that it has its own memory that recalls the previous activity and take decision with the comparison of previous and latest, right? Now this can handle sequential data, consider the current input, and also it takes the previously received inputs, then can memorize previous inputs due to its internal memory. And this was our target, right? Now let me show you this also quickly. Let's have a quick recap. First of all, the important libraries are brought here. After that, we read the Excel sheet. In that Excel sheet, there is a set of messages. For example, 1000 messages we have taken, and in another column we have written either spam or not spam, right? After that, here we are using the keyword that is ham. Okay, you can make it as no spam also. After that, you will see here we have first of all we have changed the headings. After that, you will see we will put this, since it's a RNN, so we need maximum data on in the numerical format. So for this we need ham to be denoted as 0 and spam to be denoted as 1, right? And then you will see vectorization. This is something new, TF-IDF vectorizer. So we have again separated it into two parts, that is the independent value and the y is the dependent value. First of all, after that, train test split, we have taken train test split, we have splitted it and trained that, and with the help of 70% of data is on the training purpose and 30% is for the testing purpose. After that, model loss optimizer. Okay, so we created a model here, and then model criteria and optimizer. After that, we will train the data with the help of epochs 100 we have taken, that is the repetition 100 times. After that, plt.plot, plotting the data, and here we plotted the data. Now our model says that okay, how much is the accuracy? So this is the accuracy, macro average, and here you will see weighted average. Now you will see here prediction for new messages. Now our new messages comes here, so we will put two new messages and we will check whether this machine is trained enough or not. So we have given two messages, that is congratulations, you have won a $19,000 $1,000 gift card, call now. And another is message 2, that is hey, are we still on for dinner tonight? So as the sentence clearly shows that it is written by a human and the above sentence is written by the machine. So it has identified, and based on that, here you can see, congratulations, you have won a $100 gift card. So that is a spam, right? And here is, you can see here another message, that is the here are we still on. So it's a human message written by human. So in this way we can use recurrent neural network for building any type of data or any type of prediction, right? And after that you can detect your given data, right? So this is how the complete works. Now I suggest you to watch this video again and again, and twice, thrice, at least twice, thrice, and then practice it from your side. You can get the practice data easily. There are so many sites that provide the practice data, so you can get easily anywhere and then practice it from your side. I have explained you with the daily life example also. So try to memorize that example and then try to write your own examples, right? And if you have any doubt, then you can put it into the comment box. I will reply you. And those who are new to this channel, please subscribe the channel. You will get the notifications of the latest videos. So guys, today we are concluding here only, and today we are closing the session here, and in tomorrow we will see some other interesting topics and we will discuss on them. Okay, thank you guys. Thanks for attending this bootcamp session. Thank you. See you tomorrow. We will discuss some